second screen, okay? So now we'll take a look at the introduction, if you will, into AIX, okay? And we'll begin by looking at the major components of the actual operating system, being, in our case, AIX. We'll look at the major topics that we'll discuss and cover in this particular course as part of this unit. We'll also explain the value of these topics when I'm working in our particular environment. Now, in and of itself, AIX is an acronym, believe it or not, okay? And an acronym I'll place over here, AIX, is equivalent to, if you will, okay, Advanced Interactive Executive. We used to use the lowercase e, uppercase X. Let me extend this out a little bit. Okay. Executive. Okay. So that's what AIX is. In other words, this is IBM's version of the actual Unix-based operating system. Now, what makes AIX a little bit different than most Unix-based operating systems is something called the LVM, okay, which is a Logic Volume Manager. Excuse me. And also ODM. Let me move that over. Which again is the Object Data Manager. And these are, shall we say, two other things that makes AIX a little bit different than most Unix-based operating systems. Because again, the storage, if you will, components are managed in our environment, AIX that is, from a logical standpoint. In other words, we map through the Logic Volume Manager device driver our logical to physical storage. Again, don't be confused by what I'm saying here. This is not to kind of make it hard. I'm just kind of giving you an introduction as far as what makes AIX a little bit different than most other Unix-based operating systems. And of course, ODM, but a lot of you have heard of SMIT, right? System Management Interface Tool. Okay. And in this class, we don't use SMIT for, configuring devices and configuring users, but I will introduce you to SMIT just so you can kind of, hey, I can run SMIT, play it with it for 4 or 5 minutes in our particular environment. But these are some of the things that makes, if you will, AIX a little bit different than most other Unix-based operating systems. Keeping in mind that AIX is developed from System 5 Unix, but also BSD or Berkeley Software Division Unix also, but primarily it's made up of System 5. The base kernel is still licensed from, if you will, we call it AT&T Bell Labs, if you will, the base kernel. But again, what makes AIX a little bit different is those three primary components there, the LVM, ODM, and also SMIT, okay? So when we look at this, the kernel really is the actual heart of the operating system, okay? So kind of highlight that. So with the kernel, okay, being the heart of the operating system, it says primarily here that the actual kernel, if you will, is the interface to the hardware. But it's also the interface, if you will, to the actual software. Come up there. And also virtual devices and logical devices. Okay. And that's the actual kernel. It interfaces with the software, it interfaces with virtual devices, kind of like we can create LPARs and also virtual Ethernet adapters and such, and virtual storage adapters and virtual storage, and also logical devices such as logical volumes. So that's the actual kernel being, if you will, the heart of the operating system. So in other words, it interfaces directly with the software, directly with the virtual devices, directly with the logical devices, okay? And of course, the kernel, whenever a process is created, the kernel assigns a PID or a process ID to that particular process. And again, our environment, AIX is a multi-user system, but also we can actually have thousands or hundreds of thousands of processes active on a single system at any given time. And this is kind of like our high-level overview, if you will, of the actual operating system. But what we want to understand is that the kernel is really the heart or the centerpiece, if you will, of the operating system. And it says that the kernel manages and controls processes and threads also within the actual system. So what we'll want to look at is pretty much what will we be learning in this particular course. So again, before I move to the next screen, are there any questions? Okay. And while I'm thinking about this, and while you're thinking about questions, let's kind of do this again. Let's make a little drawing here. Okay. See how good can I do this, okay? So with the kernel being, if you will, the heart of the operating system, kind of have the kernel here, okay? And draw another little outer layer. And as users, we do not interface directly with the kernel, but we do use the shell. And primarily we'll be using the corn shell for that particular purpose by default within our AIX environment. And then, of course, the actual, if you will, the application that we log into. So now we have the app layer, if you will, and I kind of put this out here outside of this. Okay? So we have an application, and then of course we can kind of say that, as mentioned earlier, that we might be logging in to the application, whatever that particular application is. So we can kind of say here, log in. All right. So that's kind of like a view, if you will, that you can look at also. Again, they have a different little view here, but we can look at this as layers, the kernel being the heart, the centerpiece of the OS, and then we interact indirectly with the kernel through the use of the shell, primarily by default, the corn shell. And then, of course, we log into an application, and that application, again, interfaces with the shell, which in turn the shell interfaces with the kernel, and the kernel interfaces directly with the hardware, software, virtual, and logical devices. Okay. All right. That works for everyone? All right. And I'll just leave it up there for a moment because it's something a little bit different. And we'll mention this layer. We'll draw this out again, probably as a review tomorrow morning, because each day we'll have a little review for about 5 to 10 minutes as far as the previous day's events, previous day's topics, and we'll go from there and continue with our day's agenda topics, if you will. Okay. So let me clear out all this. Okay. All right. Okay, working with an operating system. So in other words, once a user is authenticated, in other words, goes through the login process, authenticated by the C2, or shall we say the basic security measures, primarily on a system like in this particular environment. So the user provides a valid user ID, valid username, valid user ID, and a valid password. And that's checked, of course, in the different files as far as part of the login process. So now once the actual user logs in to the system, they can now begin to run commands. And these commands are run from a shell. By default, it will be the corn shell within our AIX environment. So the second command, third command. So in other words, working with the shell. We said earlier, previously, that the shell interacts directly, shall we say, directly with the kernel, because we as users interact with the shell, which in turn, we are interacting indirectly with the kernel, not directly. Okay, so then we can begin to run commands. Let's say here, command 1, command 2. It could be the who command as far as the which users are logged in currently on the system. We can send a basic built-in mail message. We might use some other facility other than what's built in. We can type in info center if we have knowledge center configured in our particular environment, or we can run, like, for example, the LSPV command or the LSVG command or the OS level command. So again, different commands can be executed within our particular environment. And keeping in mind that we'll speak about the shell can also be used as a comprehensive programming language. Simple, or we can make it as complex if needed or required, okay? And we'll be speaking about these things as far as during the process. So let's bring up a little new share here and see if I have that. Okay, try this one here. And hopefully everyone can see this. If you can't, okay, if you can't, let me know. And this should be a little putty screen up because I'm logged into LPAR1, one of our LPARs that we'll be using this week. And if I type in a command, for example, like the host name, excuse me for a second, please. Had to get that morning sneeze out. So again, if I type in a command like host name, or like they use the command who, again, who's currently logged in on this particular LPAR, okay? Right now it's only me. I'm logged in as a root user, okay? And then of course I can type in other commands like lspv, for example, list of physical volumes configured on this particular system, physical volume being disk, or lsvg to list the volume groups configured. That should only be one, which is root vg. There are a host of different commands that I can actually run. Or if I want to know how to use a command, for example, man on the who command, and that will give me information, which we'll talk about in Unit 2 as far as the command usage, the purpose of the command, syntax, description. So we get all that from the man pages, which again are built in to our particular operating system, which we can use to kind of find out the usage and explanation of the usage of different commands and what flags, options, if you will, can we use with those commands. So that's kind of what we see here. Okay? And let me, okay, give a new share, stop this share, go back to the screen that we were at. Okay. And, okay, everyone sees the screen here working with the actual AIX system. No problems there. Should be the same screen. Everything okay? Command 1, command 2. Okay. All right, moving to the next screen. Okay, working on or within an actual AIX system. Okay, now let's kind of again keep this free, have a lot of freedom here. Okay? So what I'll do is I'll kind of draw up, if you will, on the right hand side over here, kind of like, if you will, a storage hierarchy. Okay, so we can kind of understand what's going on this particular page. Okay, so this would be, I'll try to keep it in a white space, on our actual AIX storage hierarchy. Okay, this will be short because I'll use acronyms for the most part. So I'll just shorten up hierarchy. Okay, all right, keep it on the screen. Okay. So all storage, now all storage within our AIX environment begins with the volume group. Okay, what we call a VG. All right. And I'll just kind of draw my arrows here as I go along. Now, within volume group, we'll have one or more physical disk, which we refer to in our environment as physical volumes, okay? Text as physical volumes, okay? So again, that would be, let me get this over here. That would be PV, or physical volumes. And then from there, all storage is managed logically in our particular environment through the use of logical volumes. Okay. Now again, you don't have to remember this and hurt your brain at this point, but this is kind of like what we use in the admin class. Okay, just a little bit here. So logical volume, or LV, you hear that term called sometimes. Okay, and then of course, associated with LVs or logical volumes could be a file system. This is what we're speaking about over here. Could be a file system. Here, draw. Could be a file system. Okay. But again, logical volumes can be used for different purposes, such as for log devices and such. We'll just keep that straight in. File system. And then of course, within file systems, there could be directories or directories, and that would be our next string here. So directory or directories. And then of course, we will have finally at the bottom of this storage hierarchy, we'll have the individual file or files, okay? All right. And that's kind of like, if you will, our fundamental AIX storage hierarchy. All storage begins with the volume group. And a volume group is a collection of one or more physical volumes, okay? Then of course, the logical volume manager utilizes logical volumes to point to physical storage, or to map to physical storage, if you will. Now, logical volumes can be used for different purposes, such as in our discussion here, we'll be speaking about using logic volumes for the purpose of containing or hosting, if you will, a file system, okay? And then within a file system, there are one or more directories, okay? And then, of course, within those directories, there could be one or more files. So in our class, in this class, in the basics class, primarily we're not dealing with the volume groups. We're not dealing with the logic volumes. We're dealing primarily in this area here, files and directories. We'll be working primarily with the /home file system in this class. But again, as we go on this week, the next couple of days, I'll mention volume groups. I'll mention how we can go about potentially creating additional volume groups, but in our class, we only have one physical volume, so therefore let's use the whole root VG, but I'll show you the menus how to go about creating an additional volume group if you had additional storage, okay? So now we go back to our class at hand. We have disks, we have CD-ROMs, we have networks, okay? But then they have bolded here, file system, okay? Now, for the most part, a file system, we can define what is a file system, what is an individual file, this, that, okay? But I was trying to look ahead and see what you guys had there. But for the most part, a file system is a hierarchical, if you will, method of storing and retrieving data, okay? So in other words, instead of having all our data within one file system, we can have different file systems. What they're showing you here is we have different file system types. The file system can be hosted on a disk, like for example, in our case, a JFS or a JFS2 file system. It could be a CD-ROM file system. It could be a network file system, for example, like we'll just say here, for example, like NFS. Come on, you can do it. Give me text. There we go. So it could be like, for example, NFS. Okay. CD-ROM. Over here, our example could be on disk, like we have in the class here, JFS2. All right, in our example. All right. And within that particular file system, whether it be NFS, whether it be JFS2, whether it be CD-ROM, there could be data, again, words, files and directories associated with that particular file system. So in other words, working with files and directories here, all right? So we can have the file system could be either, like I said here, network, or it could be local. So we can kind of say over here, it could be what? We'll use the example of /home. And again, the file system can be either local, like a JFS2 or /home, or it could be a remote file system, okay? Again, it could be NFS, a file system that's hosted at a different server, if you will, okay? And in order to make the contents of a file system available, we have to actually mount that particular file system. But in our class, we're working primarily in this area down here with files and directories. So therefore, again, working with files. Files can have different protections on them: read, write, execute. We'll learn how to copy files. We'll learn how to move files, rename files. Okay? We'll learn how to add and delete files. And of course, we can edit files, or we can print those files. And in order to edit or print, one of the utilities that's available, of course, like they have there, is the VI editor. Okay? And that editor is available on this platform, being AIX, but also on most Unix platforms. A lot of people don't like that editor, including me, but liking and being able to utilize is two different things. But again, it is a useful editor for the purpose of modifying files in Unix-based environments and the AIX environment. Okay. So at this point, we have a little activity, and as you see after that, okay, we have, at the end of each unit, we'll have a checkpoint. So again, fairly easy overview unit, but we began our discussion with this interface to the hardware. This particular page here also mentioned interface to software, virtual devices, and logical devices also. And that was what? The
kernel?
The kernel. There you go. Again, use your open microphones. Again, like Heather told you, you don't have to raise your hands. Just, we're pretty inactive, okay? If you get out of control, we can take care of that, right? So, kernel, right? Come on, you can do it. Come on, you can do it. There we go. Yeah, so, kernel. All right, that would be the kernel. the heart of the operating system, the interface to the hardware, and we'll add this software, right? Okay, virtual devices and also logical devices. Remember, in our world nowadays with virtualization, we have virtual devices should be logical. Try to erase that part. Oops, took everything, right? So again, to our software, our logical and virtual devices. We'll make it the different way. Maybe I can spell it right this time. And our virtual devices, software, logical, and also virtual devices. Okay? Now the user interface. What is our user interface considered in our particular environment?
Shell.
The shell, right? The shell, primarily, it would be the corn shell by default. And I always say by default because as an administrator, we could configure users to use other shells like Bash or C or corn shell 93, for example. And then, of course, access to the data is provided primarily through the use of a mounted
File system.
File system, exactly. Okay. I'm just going to make it one word. They got it here, file system. Right? But file system, right? Okay. All right. File system. Very well. Very good. Very well. Okay. All right. So now let's do this. Okay. Let me go back to a share. And since we mentioned file system, okay, so we'll go to a new share. Okay. All right, so we'll go to a new share. So I mentioned that one of the commands that you can use to display the mounted file systems is the mount command. And this shows me, displays for me my mounted file systems, okay? There's another command also, you can use the df command. And this also shows me my mounted file systems, of course, mounted on slash, which is root, /usr. We'll learn about these different file system names in the next couple of units, okay? Not so much the mount command and the df command, but I'm just displaying for you different commands you can utilize. So feel free when you go to the lab to utilize these commands. Okay?
What does DF mean?
DF, display file systems. Yep.
Okay.
Yep. Yeah. And when you guys, are not speaking, just go ahead and mute out your mics because we're getting a lot of background there. Okay. But yep, DF is display file systems. Okay. Yep. And some of you probably ran these commands before. OS level command, okay, maybe. And that shows OS level, that shows you or displays for you. Let me clear that up. Okay. Displays for you your particular level of OS that you're at right now, like 7.1.0 for us, right? Okay. And there's, of course, different flags you can use with that also. So again, please feel free, once again, to utilize these commands within your environments, okay? All right. Back to a new share. All right. So now we go and speak about the shell, okay? And again, if you have your mic open, just go ahead and close that out because we're hearing some background there. Okay. Thank you. That quieted down things considerably. No problem. So again, the shell, the user interface into the actual operating system is always through the use of a shell, just like you just displayed for you. For me, that is displayed for you. Executing commands, all that is actually done through the use of the shell. The shell is what referred to as the command interpreter, if you will. In other words, whatever command that you enter, the shell will actually attempt to pretty much, if you will, interpret that command. Now, if that command does not exist in the kernel library, come on, you can do this. Come on, you can do it. Why is it? me my arrow. All right, well, let's try it again. Okay. All right, well, whatever, okay. So it won't let me use the arrow. So again, execute user commands, again, the command interpreter. Now the shell can be used to, let me try this, okay. Just in case. Try to fool it here. It's not having it. Okay. All right. Okay. Won't let me allow any tools. Okay. I'll work on that at the break. Okay. So again, execute user commands. That would be the actual command interpreter, or in our case, the actual shell. So the shell, and again, I'll give notes, can be used to actually automate, if you will, tasks that we repeat, or if you will, repetitive tasks. We'll be speaking primarily in this class about the shell being the actual user interface, if you will, into AIX. Okay. Can everyone see the screen that I'm speaking about? Okay. Because I'm getting a little hang on my second screen here. Executing user commands, featuring wildcards, variables, the shell being in the centerpiece of all this. Everyone sees that okay?
Edwin?
Yes.
What I'm seeing is the AIX file structure from your notes.
Okay. All right. So yeah, because that's what I'm saying. It's just a little bit of delay here. Okay. Let's see. Let me get out of that. Okay. All right. Let's go new share. Okay. Okay. All right. Now I got the green border. That's promising. Okay. All right. So now, does everyone see it now? Okay. Executing user commands, command interpreter, all that.
Yes.
Okay. Okay. Thank you. All right. Yeah, I didn't have confidence because I didn't see that green border around it on my other screen. Okay. All right. So now let's try to annotate. Okay. All right. Everything is back. So with the shell, we can kind of say the shell, if you will, it's customizable. The shell can be used for process control. The shell can be used as a programming language, and this is where I'll place my note at as far as a programming language. So we can say the shell, if you will, okay, can be used to automate repetitive tasks. Okay. All right. Uh, we can search out repetitive tasks. Excuse me. We can actually search through, or using filters like grep, okay, set, stream editor, awk, filter out, if you will, information out of files, okay. We can actually automate things, such as we can schedule tasks through cron, through the use of a shell script. So in other words, a shell can actually automate repetitive tasks, or tasks that we need to do or perform at some time later than absolute or right now. I will be speaking about some of my favorites here as far as wildcards and variables. These are some of the features of the shell. Okay? Wildcards being characters that have special meaning to the shell. Meta characters, characters like the pound symbol or the question mark, or if you will, the asterisk, that go beyond their typical use. In other words, meta characters, and these characters will have special meaning to the shell. We can actually determine how to display the value of a variable using some of the actual wildcards, actually searching through files, using wildcards, using filters, once again, like grep, to perform those searches, okay? So in other words, the shell can help us improve task, or improve task-oriented information within our particular environment, okay? All right? So this is what we're looking at here as far as our user interface into the shell. So let me clear all this, clear that out. Okay, so now we're looking at useful AIX utilities. And because I don't have page numbers, I do have figure numbers. And this is figure number 1, at least it's saying here 1-4, something like that, but I don't believe that. Actually, it says it's 1-4. Is that true? Figure 1-4? I think it's more like 1-8. Actually, figure 1-7. Figure 1-7. So again, useful AIX utilities. So we can actually, as I mentioned, search for specific files, files that might begin with the letter lowercase a, or files that might begin with the uppercase C, or files that have a certain string within them. Like, for example, the string ABC, we can actually search out for patterns within files. Okay. Okay. Why is it left over from the previous screen? This is a current screen. So why do we have this left over?
Hey,
Yes, go ahead.
what's happening there?
Go ahead.
Can I help with the screen share?
Yeah.
So what are you trying to do?
No, I was just because I had some text left over from the previous screen that was down in this area here. Okay.
Okay.
Yeah, I was wondering why it was on the previous screen.
You have to clear or erase.
Yep. Right, and I cleared all because I cleared all my drawings. So I'll just make sure I clear everything from now on. Okay.
Okay.
Yep. All right, no problem. Yeah.
Thanks.
It was just down here in this area. It's like from the previous screen. Yeah.
Oh, it's just haunting you.
Yeah, I guess I shouldn't have said nothing if you all didn't see it. All right. Okay. So making sure we clear everything here. So again, search for specific patterns in the file, or compressing the files. JFS2, which again is enhanced JFS, which we use by default with the operating system now, does not support compression of files. But again, some files can be compressed depending upon what type of file system that they actually generated from. We can actually utilize different utilities to compare files, like directory compare, or to compare files. We can actually compare the differences between file 1 and file 2. So in other words, those are utilities that we're looking at in Unit 12, Unit 13, as far as comparing files, comparing directories and such. Okay. All right. Okay. All right. And whether I write on the screen or not, annotate, I'm just going to make sure I clear all drawings before I move to the next screen. Okay. All right. Graphical user interfaces. Common desktop environment is what we're looking at here. And also AIX Windows is available, but for the most part, as administrators and such, we do not normally use these graphical user interfaces, because most likely if we're managing our particular environment, we might be logged in through PuTTY. Okay, we might be logged in through the HMC. And again, with the HMC, we might be logged into the HMC, the hardware management console, in other words, which allows us to actually manage the different LPARs in our particular environment. We probably won't be using one of these interfaces. We're probably using either the graphical HMC interface or logging in command line into the HMC. Most customers prefer to use a graphical interface, a little bit easier to use in most cases. Again, also gives you some nice visuals as far as what they look at, as opposed to the command line interface with HMC. So for the most part, some users may be using or might use the common desktop environment if the administrator permits that type of thing in the environment, because whenever we're using the graphical user interfaces, those tend to take up additional resources, which most admins don't like and don't want to support as far as within AIX in and of itself. Okay. All right. Okay. And what we'll do right now is, because we've been going for about a little more than an hour. Okay. What I'll do is, before we do the checkpoint, because at the end of each unit there will be checkpoints, and I will have the answers to those questions, but also probably in Appendix A of your student material, Appendix A, there should be answers to the actual checkpoint questions also. Every once in a while, what we have, we always write, and what the answer is could be wrong depending upon the level of the operating system, whether it's newer or older. Okay, supporting that particular question or in support of that particular question, okay? So right now, what we'll do is we'll take about and I'll place a clock up each and every time that we go on break, okay? And where did my clock go? Okay. Stopwatch, okay. All right, so what we'll do is place up, okay, a timer for about, we'll take our first break so that way everyone can get, accustomed and get refreshed. We'll take our first break being 15 minutes. Typically, our breaks will be 10 minutes, maybe every once in a while 15. We'll combine it with a lab also. But this right now, the first break will be 15 minutes, okay? So timer will be up, and go ahead, enjoy your break, and we'll see y'all in about 15 minutes, all right? Okay. All right, so it begins now, clock countdown, and I'll place my mic on mute. You might see some video, just a blank wall back here. You don't see all that other stuff in front of me on purpose, okay? So again, we'll start the clock now. See y'all in about 15 minutes. Okay, is everyone back yet? Okay, we'll just go ahead and begin with our checkpoint questions. Again, please feel free to interact directly with this. And question number one, which part of the operating system interacts directly with the hardware, the software, and virtual devices, logical devices? Which part of the operating system interacts directly there? It is who? The
Kernel.
kernel, okay? The heart of the OS, okay? And question number two, which part of the operating system does the user interact with?
The shell.
Directly.
The shell.
It's the shell. We don't interact directly with the kernel. Usually if we do, that results in some type of illegal exception or crash. Question number three, which editor is available across most Unix platforms?
VI.
VI.
VI, everybody's favorite, right? Come here, VI. VI. Okay. Question number four, what are the two graphical interfaces that we kind of had a discussion about? It was CDE and what else?
AIX Windows.
AIX Windows, what we call motif Windows, original Windows, native Windows, AIX Windows, okay? Question number five, true or false? AIX supports file systems only on hard disk or physical volumes.
False.
That's false because NFS or network file systems, right? CD-ROM, among other file system types, okay? So let me clear all drawings, okay? Go to the next screen here, and these are the answers to our checkpoint questions. And very well as far as your answers that you provided to our checkpoints, okay? Okay. All right, so summarization of Unit 1. We looked at some of the major components of the operating system being AIX. We also looked at the topics potentially that we'll be discussing in this course, among others. And looking at the value of these topics, again, that's pretty much our objectives, and this is summarizing our potential objectives, okay? So now we move to Unit 2.